So now that we've done some tessellations with some polygons, let's see if we can tessellate with some other shapes. So remember, tessellations don't have to use regular polygons or even polygons at all. We can tessellate with many, many different types of shapes. But the question is, what shapes will tessellate? Would a random shape tessellate? Probably not. But mathematicians, we like to find rules or sets of rules that can help us to find patterns to solutions for a problem. So in the question or in the problem of what will tessellate, mathematicians are actually still working on finding good rules around what shapes will and will not tessellate. But one such rule that has been found is called the translation criterion. So the translation criterion says that if a shape's boundary can be cut up into 2 or 3 opposite pairs of segments, where each pair is a translated version of the other, then the shape will tessellate the plane. Now, what does that mean? Let's see if we can understand what this is saying by actually looking at a shape. So in this shape here, let's call the upper right segment A. Now notice, if we take A and we slide it over to the opposite side of the figure, this other side, little a, is just a translated version of that side, big A. And so we can notice too that if we call this side big B, we could slide it down to the opposite side of the figure, to this side little b, and it would also be a translated version of that side. And then you may notice that this corner C is actually also a translated version of the other side's corner, C. So this means that this figure has 2 or 3, in this case 3 pairs of segments, which are translated versions of the other on opposite sides of the figure. So according to this translation criterion, that means that this shape should tessellate. So let's see if it does. So we can put a copy over here and notice that those corners fit in nicely. We can put a copy above to fill in that space and another copy. And so hopefully you're starting to see that yes, this shape will tessellate. Now in that previous example, we had a shape and we checked to see if it fit the translation criterion. But we can also use the criteria to create a shape which will tessellate. So let's just draw a squiggly line here. If we translate it over, we can create another side of our shape. And then we could add a squiggly line on the end of that piece. And if we translate it over to the opposite side here, we can create another side to our shape. And then we can connect the gap that's left between these with just another line. And it should translate into the other corner and connect those pieces there. So now what we've done is created a shape to follow this translation criterion. So that means that this shape should also tessellate. So let's try putting a piece to the right. And if we do that, you can see that those squiggly lines match up. We can also put a piece below, above, onto the left, in that corner. And so now you can see that yes, this crazy shape does tessellate. So your task now is to create a tessellating shape using this translation criterion, and then tessellate a region like a whole piece of paper. You can feel free to get creative with your shape and with your colors. So our shape, we colored the borders in order for you to be able to see those translated pairs, but you don't have to do that. You can use whatever colors you want around the edges or even color the inside of your shape.